All right, we're back. We're still on page 24 of math analysis, and we're in the middle of notes 3 at this point. And we've worked out what we are calling the unit circle definitions of the trig function. So these are the circular definitions, not based on triangles anymore, although they're originally loosely based on triangles. So like you can kind of always refer back to your triangle thoughts, right? So keep that in mind. When we start doing more problems, I will point out exactly how I do that. And it's all based on me being willing to have negative sides in a triangle. But one thing that I did want to point out here was that for this problem, we wanted to notice that some of our ratios are now negative. Which ones were negative? Well, cosine ended up negative. Secant was negative. Nothing else was negative. Now, would that have changed if we use a different point? Cosine is the x coordinate, right? Secant's the reciprocal of that. If cosine is x and you're in the second quadrant, x is always negative, cosine has to be negative, right? And then the y coordinate in the second quadrant is positive, so sine is going to be positive. So other things that ended up negative, tangent, right? Tangent, because it's sine over cosine. I think I literally forgot that that was going to happen. Like as I was talking, I was like, wait, you know what I'm supposed to be thinking about? What's positive, right? So now 4 out of 6 of them are negative. The only positives are sine and cosecant, because in the second quadrant, the y coordinate's positive, the x coordinate's negative. So anything involving the x coordinate, which is cosine, secant, tangent is sine over cosine, so tangent and therefore cotangent, anything involving x is going to be negative in the second quadrant. In the second quadrant, y is positive, so only sine and cosecant were positive. That's a big deal. All right, let's see. Now we're supposed to go to the third quadrant, so let's try to do that. So can I just copy this? I think I can. Hold on. I just want to copy my circle instead of going through that again. Duplicate and move. Okay, so I think we're good to go. So in the third quadrant, I'm going to need a triangle. So remember, the hypotenuse is always just the radius of the circle. The right angle is always going to be at the x-axis, always. So we're going to go here. You actually like don't even, okay, try it again. You actually don't even need the y-axis for this whole process. I mean, we have it, but you wouldn't really need it. So let's see, I'm going to put in a right angle here. Okay, except I'm not using a marker. Here we go. And then my point now, if I reflect that point from the second quadrant down into the third, it's just going to be negative and negative. So this will be negative 3/5, negative 4/5. But there's really nothing special about that point. It could be any point on the unit circle in the third quadrant. You get the same results. Same generalization, not the same results, obviously. So let's do it again. So sine of theta, cosine of theta, and tan of theta. I never abbreviate sine or cosine, but I often abbreviate tangent as just tan. I don't know why. But like I will argue with you about abbreviating sine and cosine, whereas I will encourage you to abbreviate tangent. So not consistent, but no one said I had to be. Cosecant, secant. I also don't abbreviate those, but then cotan of theta. Okay, so we have this, and now let's write down our values, right? So x is cosine, so that's going to be negative 3/5, and then this is going to be negative 4/5, and then tangent is sine over cosine, so it's negative over negative. So it's actually positive in this case. Positive tangent, which means positive cotangent, and everything else is negative, so only tangent, and therefore cotangent, positive in the third quadrant. So we have this. So everything is negative except for tangent, and if tangent is positive, cotangent is positive. So a lot of negatives there. And then finally to the fourth quadrant. So let's copy again. Bring it down here again. And then we got to put, so the right angle is always going to go on the x-axis, always. Also, I've like completely abandoned the notion of kind of like accurately putting this point. So that's not great, but this will be 3/5 and -4/5 for y. Okay, and now we need, oh, I didn't put theta. I forgot to put theta in the last one. Did I do it in the previous? Yeah. Okay, so theta always goes. So this is the weirdest part. Theta always goes from the positive x-axis all the way to the terminal side. So the theta that we're interested in goes like this. That's theta. It's big. It's a third quadrant angle. And then here it's going to be even bigger. It's going to be a fourth quadrant angle. Almost all the way around, right? So that's our theta. So we got sine theta, we have cosine theta, tan theta. The more you write those, the less likely you are to mess it up. Cosecant, secant, cotangent. All right, so far, okay. Now, cosine is the x-coordinate. So in this case, the x-coordinate, because you're in the fourth quadrant, is going to be positive. So this is 3/5, and so this is 5/3. Everything else is going to be negative because everything else involves y. So sine is going to be -4/5. This will be -5/4. And then sine over cosine is going to be -4/3, -3/4. Okay, so we've done it, I think, maybe. Let's like go back here and say quadrant 2. Let me use a different color. So quadrant 2, therefore y is greater than 0. Therefore, sine and cosecant positive. And then here we were in quadrant 3, which means that x is less than 0 and y is less than 0, which means the only thing that could be positive is something that uses both x and y, and tangent, because it's y over x, does. So I'm going to say, therefore, tangent of theta, which is equal to y over x, is greater than 0. And so is cotangent, but you know, you really talk about the main ones. You talk about is sine positive, is cosine positive, is tangent positive. You know the reciprocals have to be. And then finally, we got to quadrant 4. So in quadrant 4, x is greater than 0, which means cosine of theta will be greater than 0. And so is secant. But we don't, you only think about cosine. Like, you worry about sine, cosine, tangent. The other ones are just along for the ride. You know, you flip them over, it's fine. So we want to kind of generalize this and just think about it like one more time. So in the first quadrant, sine, since x is positive and y is positive, everything is positive. So in the first quadrant, everything is positive. In the second quadrant, generically, your points kind of look like negative and then a positive. So y is positive, which means that sine and therefore cosecant will be positive. Everything else involves an x, so everything else is going to be negative. Negative, negative. Third quadrant, negative, negative. So the only thing that will be positive is something that uses both x and y, and that is tangent. And then everything else, negative. And then fourth quadrant, plus minus, x is positive, y is negative. So the only thing that can be positive is things that only involve x. X is equal to cosine, so cosine is positive. Everything else is negative. And then the way that I remember this, I will just tell you in class, because I don't really want to put it in a video, but what most people do is they say A, S, T, C. So this is telling you what's positive. So it's all of them are positive. Sine is positive. Tangent is positive. And cosine is positive. So all sine, tangent, cosine. All students take calculus, I think is what people usually say. I usually So I usually use crack for C. All students take, and then whatever you want to use for C is what most people do. And then also people will frequently, if not all the time, I draw this all the time. I just draw my axes and then I fill in A, S, T, C, and then I reference that. Be like, oh, sine is positive because of ASTC. And that's kind of how I end up thinking about it. I think a lot of people do that. So this will help us because, for example, if you know, hold on, right? Say I tell you, just provide you with the information that sine of theta is less than 0, and tan of theta is also less than 0. Then the question becomes, what quadrant are you in? All right, so first thing you want to do is you want to look at sine is less than 0. Well, where does that happen? All of them are positive in quadrant 1. Sine is positive in quadrant 2. So in quadrants 3 and 4, sine would be negative. Tangent's negative. Everything is positive in quadrant 1. Sine is positive in quadrant 2, so tangent's negative there. Tangent is positive in quadrant 3, but negative in quadrant 4. Wherever I just put 2 check marks is the answer to the quadrant. So this means, therefore, you are definitely in quadrant 4. That's a type of problem that you can solve with this. It's really useful. It's also just useful to know, like, we did the principal coterminal angle thing. We figured out what quadrant some giant angle was in, right? Just figure out the quadrant. As soon as you know that the quadrant is quadrant 3, you know tangent's positive, sine is negative, cosine is negative. You just know these things. So I'm going to cut the video here. You got to remember all of it, just everything, right? Unit circle definitions, so important, must be on the unit circle. What is the feature of the unit circle that makes it work? The fact that the hypotenuse is 1, right? The radius of the circle is 1, so the hypotenuse of your triangle is 1, so every ratio reduces down. Super important. So make sure you understand that, ask your questions. I'll see you in the next video.